Welcome to a new test and teardown video. This time it's another Philips, the PM5334 TV sweep generator. This one is of course used to test television sets, the receiver front ends and IF signal path. So that means debugging the receiver. We got all those 8 different ranges for the frequency setup here. As you see, we even dial the entire readout like that. And we got a few holes in the frequency setup. See, from 12 to 30. Then we got a little bit of overlap, and there you have it. Another hole from 270 to 460. Each of these bands, that's an oscillator made with varactor diodes. So that is a variable capacitance diode. I'll probably show a little bit more in detail in the schematics how that is done. So we got some markers. And we got center frequency, that is the sweep system here. It is of course a sweeper. You can turn off the sweeper. I think if you put this in off, it should not sweep. Then you should have a permanent frequency. And yeah, well, I look forward to see if any of that is working. Turn on and off RF or modulation. That is a 1 kilohertz modulator. And sound interfrequency, yada yada, something about that. That will be the mains power on and off, and this can of course enable or disable sweep. Carrier output and RF output. I don't understand exactly what is the difference. Maybe this is the modulation. I think this is from the end of the 70s, maybe start of the 80s. I don't know exactly how old this one is. It looks to be in a pretty okay cosmetic condition, but we need to open and inspect a little bit anyway. At the back, I'm quite happy to see the good IEC standard power connector. We can see a little bit here about the model number. This is the -03 model. It does not say anything about the age. Like that. So this is the sawtooth frequency, so that is the sweep. And yeah, here we go, click. So that is 50 hertz. It could have been cool if that was locked to mains frequency. Maybe it is. And there you have a little bit of variable. Sawtooth frequency out, maybe for a scope or something like that. Maybe you can adjust the amplitude right there. The first view inside is something really funny. Look at the dirt here at the frequency indicator roll. Can you see the dark stripes and the air conditioning holes at the top? I mean, it looks like the dirt stripes align. So that means if this one is located right there, all the dirt that comes in goes directly to the most visual of all locations in this unit. I mean, come on, Philips. If the holes, they could have been just a little bit like here. I mean, all the dust will go somewhere else and not on the most visual, the most white part. That is probably not the most brilliant idea. Wires hanging all over the place here. I mean, what kind of spaghetti is that? I don't know. That is a little bit unexpected to see the frequency indicator like that, and then all this spaghetti poo all over the place here. Could this be a... is this really original? It cannot be, can it? And this little circuit board up here, I don't know. I better go and have a little deeper look. So there's a big solid box up here. I expect this one to contain all the different oscillator modules. So I better open and have a little look. Here is the bottom side of the main circuit board. It's a really beautiful circuit board layout. And of course it's all manually done. And look at that. Not Mende. This is not a Philips brand. So maybe they bought this circuit board from somebody else. Or the whole design maybe. I will look a little bit for logos like that. Maybe this is the mains entry filter or voltage selection kind of stuff. We got the mains transformer right here, and it looks a little bit like that, wouldn't you say, with those capacitors and stuff going on there. Probably for, yeah, that is definitely what it is, right? I think this whole board flips up. If I loosen those two screws there and there, then I can probably flip this up and then we can have a look. There's already one little detail I want to investigate, and it is that transistor there. This one looks like it's running warm, but I'm definitely looking for lead capacitors or any other things. This is also not super duper good. So what is going on here? The wire spaghetti is, well, there's a thing. I was right about the circuit board can tilt up, and it is a double-sided circuit board. So I'm a little bit impressed about that. We also see a little bit of tantalum capacitors now and then. I'm looking for date codes, but I'm also looking on leaked parts and what stuff is, oops, and there's another one right there. Some little stuff that may be leaked from that capacitor, but that was easy to clean away, so I don't really have a lot of leaked or anything like that except right here. But it can also be because this here is the bottom part, so the holes, the air ventilation holes that will allow dust and little funny debris to go onto the circuit board here, especially in this portion of the board. So that explains probably the dirty situation right here. Yeah, that is the spaghetti here from the other side. There's one little wire here you need to detach from this point here, otherwise you can't flip up the board. And here is the sweep control board with the switches and potentiometers for that sweep stuff. And this is another one of the RF boxes. We got a little bit of what is that? Corroded nastiness. So are they connected together, those two? When I crank the... No, they are not. So that one is the sweep system, and that will be the frequency bands, the other one. Okay, interesting. There's one screw missing right there, and it looks like the thread was missing in the metal, so that is why they just didn't put it in. And that is a carousel switch for all the different oscillator bands. Just beautiful. So that one here with all the windings, that will be the 3 megahertz one, and this one is the 860 megahertz. So this is just one tap and one oscillator winding on that one. And then of course here is the variable. Yeah, so there's not a lot to talk about in this module. This is very much like I expected. It looks a lot like a TV tuner of that time. Meanwhile, I also found this black wire is just a chassis connection. It went behind this circuit board and behind some components. So I had the idea it was connected down here, but that was not the case. It is supposed to go like that. So it is, of course, possible to have it powered up and still be able to access everything from both sides. Very, very service friendly unit. I really like when people design products definitely designed for service. So I'll try and put this down again. I think I'll leave this box open for now, and let's go and look at the other side. It is just beautiful. So here is the carousel switch underneath here. We've got some oscillator boards, some modulation boards, sweeper boards, and all that kind of stuff. That will be the different band amplifiers and filters that is going on right here. And that is the output connector that goes down here and through the bottom. Here is the connector that goes to that one. And then it goes to the output attenuator somewhere. I am a little bit impressed. It is super, super beautifully done here. So I kind of forgive them all this spaghetti wiring. We got some really, really beautiful boards and all this stuff that is really important. That is done nicely. Yeah, well, maybe except those dingly dangling boards. Let's try and pull up one. So that is, of course, the two lowest frequency bands. We've got two bands on each board, by the way. You can see the two halves, they look quite symmetric, and that is how it's done. I believe we got some diodes that switches the different parts of the circuit in and out. And there you have it. You can trim the different things in here. And all the boards there are made by North Mende. And I don't know if anything here should reveal the date. It looks a little bit home soldered, and they forgot to clean this. But the connector is pretty good. So here, the right side of the unit, there is some sort of a plug-in module available, and it is not populated in my unit. It looks a little bit like a VO board or a prototyping board, but it is not the case. Got some DC lines and a little signal cable, maybe some modulation or something like that. I found a quality issue I would like you to see. And this is unfortunately something that is not particularly rare. Those little metal things you see here on the screws. How much do I need to touch them, see? Before they... Oh, see, here you go. See? Somebody's been tightening those two screws and then creating those little metal splinters here. So where are they going to fall when they fall? They will fall down to that circuit board. and create all sorts of short circuits and instability and weird errors. Not good. So is this, here's power. And it's using 16 watts. I go for the 7 to 12 megahertz here, and I put this for 10. I don't know how easy that is to see. I don't see anything here. Ah, maybe that is why. Carrier amplitude. So here there is a little bit. I better start recording here because I think this thing is going to blow up in a minute, because I've just heard some really nasty sounds. I don't know exactly what to give of it. Now it's using about 15 watts, and I got this carrier here. It is 10 megahertz. I don't know if that is easy to see, but that is 10 megahertz. And the thing is, you adjust the center frequency here until it is accurate, and I can put this to 10 like that. And then here you have the amplitude, how much sweep you want. And as you see here on the scope, the more I sweep, the more it goes like that. And then I can of course zoom in, and there you have it. Now this is a really aggressive type of sweep, but this one can really do a lot of sweep. Like crazy, to be honest. I am a little bit impressed how nice and smooth all this works. So here's a carrier. No, this has no meaning. So here's what I did. So there's a marker modulation stuff here. If I click this one, something really weird is gonna happen, and it goes from 15 watts to a lot of watts. And try and listen to what's happening. Amplitude quota, and then 30 watts, and then 37, and then back again. So there's something defect with this system here. So how about this? Modulation here is not a problem. So this kills the RF. But this one is definitely not good. What is going on here? I just left this in for a little while before, and then I heard some sounds that was not supposed to sound like that. What else can we do if we turn off? Sweet. Okay, so that is how it is. Modulation here and blanking. So now it shows that it's also blanking if we sweep this out. See, now we get these, and now this is controlled by the 50 hertz. See, there you have the sweep, and then I can, yeah, exactly. Then I can move. How nice. This is of course interference with the oscilloscope and the timing and the resolution that I have digitally here on that one, but there you have 1 kilohertz modulation, sound something. Well, so we have a super sexy sweeper, and we can turn the sweep off, and we can turn the blanking off, and there you have it, a nice and stable and quite accurate sine wave oscillator that will do almost any kind of crazy frequencies. So that is 6 point. Aha, so you need to calibrate this every time. So I'll move this to 6. this does not change anything here. It has something to do with the sweeper. I am learning all the time how this unit works. So when I'm doing the sweep, there you have it, with this one probably. Okay, well, interesting. So this is the variable frequency, and not this one. Okay, well, pretty fancy.